Good evening, everyone. Once again, welcome back to the Vanguard. This is the second session of Veritas Vanguard 1.0. Yesterday, we kicked things off with an incredible deep dive into the fundamentals of forensic science. Today, for the second session, we are moving in to two of the most critical and classic disciplines of forensic science, that is, fingerprint science and question documents. These domains are the bedrock of identification, whether it's a latent print on a glass or a forged signature on a property deed. Today's session is about uncovering the identity behind the crime. We have a power packed panel today. We are joined by a specialist in the document examination domain and a familiar face who will be sharing her technical expertise. So, first, allow me to introduce our domain expert for the day, Mr. Mahanthesh Gowda C. Mr. Mahanthesh is currently a forensic research assistant at Garden City University, Bangalore, where he has also completed his master's in forensic science. His expertise is laser focused on the exact topics that we are covering today. He has conducted extensive handwriting analysis and forgery detection on over 150 plus samples and has processed more than 10 crime scenes, ensuring evidence integrity from the ground up. He is also skilled in the development of latent fingerprints using chemical and physical techniques. Beyond the lab, he holds certifications in the penetrating testing and forensic accounting, making him a versatile asset to the field. Please join me in welcoming Mr. Mahanthesh Gowda. Next, I am delighted to welcome a speaker you already know well because you have seen her energy as a host, but today you will also see her depth as a scientist and innovator. Please welcome Miss Mansha Negi. Mansha is also one of the program coordinators or the internship coordinators for this internship, Veritas Vanguard 1.0. She is the founder of Evisphere Tech and a dedicated researcher currently pursuing her master's at Punjabi University, Patiala. She holds an impressive academic record with a 9.9 CGPA in her bachelor's. Her practical experience is extensive, having served as a trainee at the District Forensic Science Laboratory, Muradabad, where she handled critical cases in the chemistry and toxicology division. She is also an award-winning researcher, having presented her innovation EviChain at the Next Gen Forensic 2025 conference. Today, she steps away from the podium and into the classroom to share her knowledge. Welcome, Ms. Mansanegi. Over to you, speakers.
Thank you, Swapnil. Thank you for the introduction. So, as Swapnil said, we are done for the introduction session now. So let's dive into the topic now. Is the screen visible? Can anyone just let us know?
Yes, sir. The screen is visible.
Okay. As Swapnil said, today the topic will be on fingerprints and question documents. So we have named this as prints, papers, and the pursuit of the truth, fingerprint and question documents. So me and Mansha will be taking over the topic. So why fingerprints and documents matters? So as I guess everybody are from forensic branch itself. So why fingerprints and document matters? Can anybody just brief, like if you know, can you just brief regarding fingerprints and documents?
Good afternoon, sir. The fingerprint is basically the unique identification of any case, and documentation it makes the thing more unique. Like is either in a document, we can examination of the document, we can get the idea that whether it is forged or whether it is genuine.
Okay, so as one of the Indians said, fingerprints and question documents form two of the most important pillars of forensic investigation. Every crime leaves behind traces, either through physical contact or communication. Fingerprints provides us physical evidences. They directly link a person to an object, location, or weapon. Documents basically provides us intentional evidences. As documents we get through crime scenes reveal motives, attempts to cheat, forge, threaten, or deceive the things. Together, these two forms of evidences help reconstruct the events of a crime, verify or contradict witness statements, and often decide whether a suspect is truthful or lying. Both fingerprints and documents. So in real cases, both fingerprint and documents evidence together creates a stronger multi-layered chain of proof where fingerprints leaves us physical evidences and documents leaves us the intentional evidences. So what are fingerprints? Fingerprints are patterns formed of friction-rich skins on the fingers, palms, and the soles. These patterns develop in the fetal stage, that will be between 10 to 16 weeks, and remain unchanged throughout the life. So fingerprint identification will be based on three levels. One is on overall patterns, that will be loops, holes, or arches. Level 2 details will be of minutiae details, that will be ridge ending, that will be like I'll explain later. Level 3 will be ridge edges, pores, or incipient ridges. Because fingerprints are unique and permanent, they are used in policing, immigration, biometrics, other authentication, and for identifying unknown persons or criminals. Each print is a combination of overall pattern plus minute ridge details. So this is basically on a type of fingerprints we find at a crime scene. So there will be three types of fingerprints on a crime scene. Like I can't say that all the three will be at the same scene, but there will be types of fingerprints that will be visible. One is latent prints, that is invisible or barely visible, that can be created by sweats or oils or amino acids that's provided by the skin. They require development using powders or chemicals. If you guys completely are from forensic, you'll be knowing regarding powders that will be used to develop fingerprints. And this is the most common type of fingerprint that's found in crime scene. So next one will be patent prints. That's clearly visible when there is a print left, when there is a fingerprint left behind that is made up of blood, ink, or grease, or dust, or paint, anything. So this will be clearly visible, and this can be easily photographed directly. So next one will be plastic prints. Three-dimensional impression on soft surfaces like soap, wax, clay, or wet paint. When the crime scene has any wet paint in the crime scene, so we can find some fingerprints on those wet paints itself. This provides the best depth and ridge details. The type of print depends on the surface, environment, and the nature of the contact too. If the crime scene is left behind any wet paints and there's a fingerprint on that, that will be considered as plastic paints. And if the criminal or the person or the accused will be having the paint on their hands and later the prints will be left, that's under patent prints itself. Principles of fingerprint identification. So these are the fingerprint identification principles, which will be more of three types. One is uniqueness, individuality. So there's a uniqueness in the fingerprint that no two people share an identical set of ridge characteristics. So not even identical twins. Individuality comes from the number, type, and arrangement of minutiae. There will be minutiae characteristics in each of the fingerprints, and that differs as from the others. So next one is permanence. Fingerprint ridge patterns remains unchanged from birth to death. Even after superficial injuries, the pattern reforms based on the dermal papilla layer. So even after some injuries, the pattern reforms again. The fingerprint remains unchanged from the birth to death unless and until the skin layer is washed off. Like not in most of the cases, but that will be among the rare cases itself. Am I audible?
Yes, you are audible.
Yes,
Yeah,
sir, you are
okay.
audible.
So next one is patterns. That's completely basics of the fingerprint. Yeah, the patterns. Just a second. Sorry for the delay, guys. So rich characteristics, that will be of minutia characteristics. Identification is made using ridge endings, bifurcations, islands, and other minutia. There will be minute characteristics among the ridges. So we need to identify those rich characteristics that will be unique among the fingerprints that can be used to clearly identify and classify the fingerprint types. While comparison, these minutia characteristics play a vital role, very important role while identifying the both questioned and the known samples of the fingerprints. Identification is based on number and arrangement of the minutia, not just overall. There will be count of the number of minutia characteristics also. These principles have been validated by more than a century of forensic practice and are widely accepted in courts. These minutia characteristics are most preferable evidences among the fingerprint classifications. Making latent prints visible. This is the most important thing any forensic scientist will be doing. Developing latent prints depends on the surface type and the composition of residue. So there'll be various types of surfaces where the fingerprint will be left, such as porous surface, like any paper or wood, something like that, and non-porous surfaces like glass, metal, and plastics, which will be very clearly visible. Physical methods will be used for mostly for non-porous surfaces. Black, gray, magnetic, and fluorescent powders. These are the type of powders that will be used to develop latent prints. So these will be used for non-porous surfaces. These powders adhere to moisture and oils, whereas if we use fluorescent powders, they glow under ALS for better contrast. So fluorescent powder basically have the nature of glowing. So next one will be chemical methods for porous surfaces. So ninhydrin method will be used, which reacts with the amino acids producing purple prints. So there will be amino acid residues left behind from the fingerprints. So when we use ninhydrin chemical methods, so the amino acids, when reacted with ninhydrin, turns purple. So this is one of the chemical techniques. So next one will be iodine fuming. So this iodine fuming temporarily browns the prints. For example, if there's any residue from the fingerprints left behind, when we follow these iodine fuming technique, they'll brown the prints for temporary time. So this is used for old documents when we need to use fingerprint analysis for the old documents. Most preferably, iodine fuming will be used. I'll share the images later to Swapnil regarding these all the chemical methods. So Swapnil sir will be sharing with you guys. So silver nitrates. silver nitrate basically reacts with salts in the sweat. There will be salt residues from the sweat that's left behind through the fingerprints. This can be used for older prints too. So in that thing, silver nitrate will be used. Cyanoacrylate fuming. This is also known as super glue fuming, where this creates white polymerized prints on metals, plastics, or weapons. So when we use this cyanoacrylate fuming, there will be white polymerized prints left behind, which will be easily visible, and that can be developed on metals or things. Light-based methods, as I mentioned, ALS during the fluorescent powders too. So ALS helps visualize faint or fluorescent prints. So ALS, when we develop a fingerprint using fluorescent powders, so ALS is the techniques which helps us visualize a faint fluorescent prints. So basically, when you develop latent prints on any surfaces, choosing the appropriate method is essentially because applying the wrong one can destroy the fingerprint. Even if we use physical methods on porous surfaces or chemical methods on non-porous surfaces, then the evidence is lost. No, like the fingerprint will be destroyed permanently. That cannot be retrieved again. So question documents. From now on, Mansha will be taking over regarding this question documents. So it's up.
Okay, thank you, Mahanthesh. And good evening, everyone, once again. This side, Mansha. Okay, so can you move on to slide number 7, Mahanthesh, please? Yeah, thank you. So what is a question documents? All right, we are shifting our gears from fingerprints to paper trails. A question document is basically any document where something feels such, the authenticity, the signature, the writing, the content, anything is in doubt. This could be a check, a certificate, a receipt, an ID, a will, even a threatening note someone thinks that they can get away with. When a case comes in, a forensic document examiner doesn't guess. He or she compares, analyzes, and lets science speak. Paper remembers everything, even when the writer tries to hide. Next slide. So moving on to our next slide, we are having common document offenses. Okay, document crime is basically creativity gone wrong. This is very common to everyone. The most common thing we see is the forgery of signatures, especially on checks, wills, or our agreements. Then there are alterations, adding a digit or overwriting or using chemicals to erase something. Then we also deal with counterfeiting, that is, fake currencies, fake stamp papers, fake certificates, and fake IDs. And the last and the spiciest category, that is anonymous or disguised writing. People try to hide their own handwriting by changing slant style or switching to block letters. But guys, trust me, habits leak through. The hand betrays the mind, even if we try to hide as much as we can. Next slide. Thank you. So we have security features in authentic papers. First, here's what document science becomes world building. Official papers are protected by hidden security features, just like a bank vault. We look for watermarks, security threads, microprinting, UV features, holograms, and optically variable inks. These are used in currencies, passports, stamp papers, and degree certificates. Okay, the beauty of the security features. Most of these features are invisible in normal light, but expose them to magnification or UV light, the truth jumps out like a neon sign. We can see the hidden security features in the UV light. Either it is of, the blind people could not, just wait. No? I have a call, just wait. Okay, sorry. So the blind people could not see some of the features or anything. We have some of the features mentioned on the right or left margin of the notes, like that. And for the UV light, we have a couple of features like on the back side or the over side of the notes. Okay, next slide. We have tools of the document examiner. If you think this job is just holding a magnifying glass, so I'm really sorry to break the illusion. It's way cooler than we know. We use microscopes to see stroke directions and paper fibers. A video spectral comparator, that is VSC, it helps to catch different inks, obliterations, and hidden changes. ESDA, that is electrostatic detection apparatus, reveals indented writings on pages underneath like ghost of past sentences. Spectroscopy, that is Raman spectroscopy, infrared spectroscopy, UV visible spectroscopy, it lets the examiner to chemically profile the inks. And yes, digital scanners and enhancement softwares are now standardized. Modern document examiners are half of the scientists and half of the detectives. Next. Next, we move. Yeah. Mahanthesh, please.
So guys, from rich patterns to numbers, AFIS. So basically AFIS is automated fingerprint identification system, the supercomputer behind every fingerprint match. So just imagine trying to manually compare one fingerprint to 10 lakh fingerprints in a database. So it would take years. AFIS does the same job in less than a minute. AFIS is the brain of modern fingerprint forensics. It combines computer vision, mathematics, and biometric science to convert rich details into digital templates. So basically, how automated fingerprint identification system works. First, capture. The fingerprint is scanned and photographed. Even smudged crime scene prints can be enhanced before feeding into AFIS. Next, extraction. The software identifies minutiae characteristics such as ridge endings, bifurcations, ridge flows, core and delta points. It converts this into a digital fingerprint map. Next, matching. AFIS compares the map against millions of stored prints in seconds. It doesn't give one result, it gives a ranked shortlist of possible matches. So it doesn't give us the result exactly, but it ranks the shortlisted of possible matches. So next, human verification. Once all the three steps is done, next a fingerprint expert manually verifies the matches. So we need not to work on all the millions or lakhs of fingerprints. AFIS will give us a shortlisted things of the probable matches of the fingerprint. So next one, we'll take over from there. A fingerprint expert manually verifies the match. Only after visual confirmation, identification is declared. So where basically AFIS is used: police criminal databases, Aadhaar verification, border security and immigration, background checks like job checks or passport background checks, disaster victim identification. Most of the fingerprint experts face their problems during disaster victim identification thing. So AFIS will be most easiest thing while doing this. So AFIS is not just a machine, it's a silent detective sitting behind every major investigation. This helps investigation a lot. So next, challenges in fingerprint work. Basically, fingerprint are powerful, but not always perfect because there are many challenges during this. Fingerprint science is extremely accurate, but in real life crime scenes, that's a messy. Not like some TV shows that we'll usually see, not exactly getting the fingerprint, comparing, and yes, it's done. No. it's not like that. Real life crime scene are too messy to find the fingerprints in the crime scenes. So basically, there are many challenges. Among them, one is poor quality prints. Most of the prints at the crime scenes are partial, blurred, smudged, or distorted. Only 10 to 15% of the required recovered prints from the crime scenes, just 10 to 15% are AFIS ready. So remaining almost most of the prints will be blurred, partial, or smudged fingerprints. A fingerprint on a gun recovered after 3 days of the crime scene is nothing like a clean fingerprint on a glass. So we need to face all the challenges. We need to come back by destroying all those things. So next one is difficult surfaces. Developing a fingerprint on difficult surfaces is one of the most challenges too, like texture surfaces that breaks the ridges. If the like grip of the guns, so those surfaces will be textured. So we'll not be having continuous fingerprints. There will be ridges, breakage in the ridges. So we can't identify minutiae characteristics on those things. Curved surfaces too, like bottlenecks or doorknobs. The fingerprint will be cut, the ridges will be cut down on the doorknobs too. That will be disturbed ridge flow. So next one is dusty, oily, or wet surfaces. Dusty surfaces, oily surfaces, and wet surfaces reduce the visibility. So next one is environmental effects. Heat evaporates the sweat residue. Rain or water washes away the prints. Sunlight degrades the organic components. So if the crime scene is completely in a sunny day, in a sunny environment, a single hour of sunlight can sometimes destroy what could have been the most important print. So you will be missing the important print among the evidences which can be used to solve the case. So even the environment is a challenge for us during the fingerprint development thing. So as there is an environmental effect point here, so I'll be allowed to mention a project or research that was carried out by Karnataka FSL team, as one of my professor was also in that team. So there was a mock crime scene that was created under the supervision of the director of Karnataka's Forensic Science Laboratory, that's in Bangalore. There was complete continuous 2 hours of mock rain, like artificial rain that was made to fall on a mock crime scene. Later, the team there created a history by developing all the prints that were on the crime scenes that were noted. So even after so much challenges, they created a history by developing the fingerprints in a rainy environment too. So next one is overlapping prints. Door handles, mobile phones, or car interiors often will be having multiple people prints stacked together. So this makes separation difficult. Next one is human factors. While developing or after developing, while analyzing the fingerprints, human factors like bias and interpretation of others in the evidence alteration or manipulation of the evidences. Examiners must avoid bias from police expectations. So in some cases, there will be influence from the police on the examiners too, that even if the fingerprints are not accurate, not exactly, if it's not matching to, we need the fingerprint to be matched. There will be pressure from the police side itself. So wrong conclusions on the stress on fingerprint examiners also, that results in the wrong conclusions also. If the poor quality prints are over-interpreted, so the wrong conclusion may also lead to wrong conviction too. In fingerprints, confidence comes from the clarity. never from the assumption. So we need to focus on the clarity that's main for us, not on the assumptions of anyone. So development advanced latent print techniques. So special techniques used when regular methods fail. We will be using this advanced technique when normal regular methods fail. This slide is about the secret weapons of the fingerprint experts. These techniques recover prints that are old, weather damaged, on difficult surfaces, or almost invisible. Let's explain each technique in an exciting way, as you guys won't be bored. VMD, vacuum metal deposition, the most advanced technique used in high profile cases or cold cases, involves depositing ultra thin layers of gold and zinc inside a vacuum chamber. The metals naturally stick to the fingerprint residue, creating a sharp print. So in VMD, there will be deposition of gold and zinc metals on inside a vacuum chamber on the fingerprints area. The metals naturally stick to the fingerprint residue, where one will be depositing on the fingerprint ridges and one will be depositing on the empty spaces. So why VMD is special? This can develop decades old prints. Works extremely well on plastics, tapes, glossy surfaces, and old evidences too. Reveals level 3. As I said, two metals will be getting deposited on each of the things. This will be even revealing the pose of the fingerprints too. Next one is SPR, small particle reagents, the only method that works beautifully on wet surfaces. This is a very effective method that will be on vehicles after rain, metal surface, and wet glass. As I said before, as I gave the example of Karnataka FSL people, this technique works very effective on vehicles after rain, metal surfaces, and wet glass. So this will be as spray the reagent, particles bind to the lipids, print appears. 3 steps, but it's not as simple as said. So for example, this technique will be used, can be used in the cases where a knife thrown in a lake can still give us prints using this technique. If there is a weapon of a murder or any crime, if it's even thrown in the lake, even if it's in a wet surfaces, SPR will be giving us the prints. Next one is fluorescent dyes or powders. So this is a technique where it makes fingerprints glow like a neon signs. This is used under ALS, alternate light sources. This helps in complex backgrounds, multicolored surfaces, currency notes, plastic covers, or electronics. So when the background is not still in one color, and if it has many colors combined, so a fluorescent dyes will be used as both powders, normal powders. If they fail, fluorescents will be used, as this can be differentiated based on, like, this can be different when compared to the background itself. So nanoparticle powders, super fine powders, which will be giving us super sensitive prints. So nanoparticle powders stick better and show sharper details, as normal powders will be having more larger particles than this. It will be super fine powders. This shows us the sharp details, very sharp details, and even minute things. This will be mostly used in old, degraded or delicate surfaces. This is best for sensitivity also, sensitivity that's found in the fingerprints. So basically nanoparticles powders will be like microscopic detectives. They go where normal powders can't. So that's the thing. Mansha will be taking over this one.
Okay. Can you please move on to the next slide?
Yeah, this is the next one.
Okay, thank you. So, handwriting examination basics. So, let me tell you the fun fact that no one writes the same way twice, not even you. But we all have a unique system of habits that we never notice. A handwriting examiner looks at slant, spacing, size, pen pressure, connecting strokes, how letters start and end, and weird personal quirks. The key is comparison. Questioned writing versus known samples. Same condition, same pen type. We are not guessing anything. We are observing measurable features. Next. Types of forgery. Okay. So there are four main ways a handwriting get faked. Okay, so simulated forgery, someone practices your signature like a chameleon but ends up with tremors, slow movement, blunt endings. Next, we have freehand forgery, no model, usually sloppy. Then we have traced forgery, carbon, lightbox, indentation, always unnatural line quality. And last is disguised writing, someone trying to hide their own writing style. So, you guys know what's the plot twist? Most forgers fail because they focus on shape, while genuine writing is controlled by habit and muscle memory, the most important part. Next. We have detecting alteration and erasures. People think they can erase evidence, but paper snitches. There are mechanical erasure, scratching fibers so the paper looks disturbed under magnification. Chemical erasures leave discoloration or damaged fibers. Next, addition and overwriting shows different ink shades visible under VSC. And last, we have obliterations, that is, the thick strokes to hide something that become transparent under infrared. We also study line sequence with stroke lies on the top. That detail alone has convicted fraudsters. Next. We have ink and paper as chemical evidence. Inks aren't just blue or black. We analyze them using thin layer chromatography, high performance liquid chromatography, gas chromatography, mass spectrometry, and Raman spectroscopy to identify dyes and solvents. Two pen can look identical but be chemically different. Paper analysis reveals fibers, fillers, coating, and even elemental difference under SEM EDX. Sometimes we do relative dating, proving two entries were written at different times. That moment when ink betrays a backdated contract. Next, we have digital question documents. So today, fraud happens in Microsoft Word more than the pen and paper. We look at fonts, alignment, spacing, even pixel artifacts from copy paste. Printers have toner signatures and class characteristics, even. Just because it's printed doesn't mean it's safe. Digital forgery still leave footprints, just not the kind you see with the naked eye. Next. Okay, so we'll be handling.
So AI and machine learning in this field. So as everybody knows, as there's a talk now that AI is the future. So even I'll be saying the same. The future of fingerprint and document examination is AI. Not completely, but yes, that will be useful too. AI in fingerprint recognition. Deep learning models classify patterns, match minutiae rapidly. AI model detect patterns much faster than traditional I guess, alone. So next, they can classify loops, holes, arcs automatically. That's the type of fingerprints. And AI extracts minutiae even from low quality or smudged printers. Sorry. As this can be said in a simple way, if a print is too smudged for a human examiner, AI can still find hidden red flow patterns. Next, AI in handwriting and signature verifications. AI analyzes stroke direction, pen pressure, writing rhythm, spacing patterns. So this helps detect forgeries or disguised writings. This is mostly in few private companies, as I have seen personally in Bangalore. This helps detect forgeries and disguised writings. And by using AI, they'll be developing digital signatures comparisons. I mean, digital evidences or photographs of the signatures that will be available. They'll be using AI for their examinations. Next one is AI in document fraud detection. So AI detects inconsistent fonts and alignments, identifies cut paste edits in PDFs. So as Mansha said previously, in digital evidences, digital documents, AI will be detecting cut and paste edits in PDFs, spots mismatched compression artifacts or pixel patterns. So this can be used in fake certificates and ID cards that are now caught using AI-based pattern analysis. As we have seen many cases regarding fake certificates, fake ID cards, fake degree certificates, everything. So AI can be used to identify this thing. But there is one more important truth for you guys. AI is fast, powerful, and accurate. Yes, that's true. But it can never replace human forensic experts. Human forensic experts are the ultimate thing when compared to AI. Yes, AI can be used, but it can never replace us. Code requires explanations, interpretations, expert witnesses, human judgments that cannot be done through AI, that need to be done by the human forensic experts itself. AI is the assistant, whereas forensic expert is the authority. We can just use AI as the assistant itself, but we cannot rely on them for the everything. We'll be just operating AI that itself. Yeah. Next one. Yeah. Mansha?
Yeah, okay. So when prints meet paper, the combined evidences. Okay, often the both type of evidence appear together, and fingerprints on a fraud check or a fake certificate, latent prints on a threatening letter or a ransom note, as I had told you before, and the combined analysis, the comparison can show who handled the document and how was it handled and when was it prepared or delivered, and it strengthened the overall evidential value instead of relying on a single source. Next. Okay, so next is law and courtroom aspect in India. Under Section 45 of the Indian Evidence Act, expert opinions on handwriting and fingerprints are relevant. Section 73 lets the court compare the writing itself, the golden rule, when testifying to be clear, be honest, and don't overclaim. The job isn't to impress the judge, it is to explain science in simple and unbiased terms. Next slide. Ethics and limitations. A forensic expert isn't a hired gun. You can't bend evidence to fit a theory. Never claim 100% certainty with poor quality samples. Document everything, methods, finding, and limitations. Respect privacy, especially in digital and biometric cases, continuous training matters because complacency can destroy justice. Next, I think we have case study. Can you move on to the next? Okay. Okay, I will be giving a short summary about this case study. This is the classic Indian legend of document fraud. Millions lost in fake stamp paper. And what cracked the case? Tiny scientific observation, wrong fibers, missing watermarks, defective threads, and printing errors. Forensic document examiners didn't arrest anyone. They just proved the papers weren't from the authorized presses. And that evidence was enough to collapse a multi crore racket. That is the tiny details and massive consequences. You can move on to the case study number 2.
Yeah, it's like that's it, right? Case study 1.
Yeah, you can move to the second one.
Yeah, okay. So guys, let me tell you about one of the most surprising biometric cases ever reported in India. Like, this is something that actually shakes one of the core forensic principles we rely on every day. So basically, we, the all the forensic scientists confidently say that fingerprints are unique to every individual, even to identical twins. We even teach that identical twins share DNA, but they never share fingerprints because rich patterns are found by random pressures, movements, and environmental factors inside the womb itself. But this Kanpur case that was presented gave an extraordinary twist when the twin brothers Pradal and Pavitra Mishra, yeah, Prabal and Pavitra Mishra, when these twin brothers went for Aadhaar verification, the system simply couldn't tell them apart. Their fingerprints and retinal scans were so similar that updating the biometric of one twin caused the automatic deactivation of the other twin's Aadhaar, as if the system believed that they were the same person. For the biometric database, their identity literally overlapped. From a forensic point of view, this is extremely rare and scientifically intriguing case. It challenges our long-standing belief that every forensic expert believes that fingerprints are unique, that's absolutely unique. But this case challenges us on that same point of fingerprints that it's not absolutely unique. Just imagine that if a national level biometric, that's Aadhaar, the Aadhaar system itself has got confused regarding this. What would happen if these twins fingerprints are found in any crime scene investigation or courtroom identification or a missing persons case? Just imagine what if one twin is here, and like if the other twin has committed any crimes or any courtroom identification, if there's both retinal prints and the fingerprints are same, just imagine the consequences. A fingerprint match could falsely point to the wrong twin, and an automated system like AFIS might flag both individuals as the same suspect. This is why forensic science never relies on a single clue. Cases like this highlights the importance of multi-factor identification, combining fingerprints with DNA profiling, ear morphology, gait analysis. As most of them will be knowing gait analysis. If not, gait analysis is that something that will be analyzed, that is used to analyze the walking pattern of an individual. Gait analysis, as that's the point of gait analysis, even though it's not related to FP and QD, let me tell you, there was a case known as Gauri Lankesh case, where Gauri Lankesh, a familiar press reporter or activist, was killed in Bangalore. the case was completely going towards named as cold case, but gate analysis pattern were used to identify the criminals. So this can be related to fingerprints, facial features, behavioral patterns, and other forms of the evidences too. This incident is not just a rare curiosity, it opens new research questions for us as a forensic expert. How close can biometric similarities actually get in identical twins? Do environmental factors sometimes produce unusually matched read patterns? Is that true? How can forensic systems be improved to identify individuals when biometrics overlap? This is the first case that's been reported in India. If this is the first case, so we need to be developed in fingerprint identification things where there'll be more needed. As I said before, fingerprints need to be linked, like that can be linked to DNA profiling, facial morphology, and multi-factors in a human being, not just relying on fingerprints itself. In short, this case serves as a powerful reminder that even our strongest forensic tools can encounter exceptions, and those exceptions are what push the science forward. These things, if something like this happens, we'll be knowing that yes, there is a need of more development of the technology, techniques, and everything in the fingerprint identification techniques too. So, Mansha.
Yes. Okay, we are going for the activity part, I think so, no? Okay, so these were the slides explained by us, and we will now going for the activity part 1. Okay, so you have to compare the two given signatures and observe their basic features like letter shapes, slant, spacing, and line quality, and also note the similarities that show natural variation and any differences that look unusual. After observing, write a short summary of what matches, what differs, and whether the variations seem normal. ठीक है. Okay, first of all, जो भी हमारे बैचलर्स का स्टूडेंट है, I will be telling you a bit, basic about the signature analysis. ठीक है. So basically, in signature analysis, it's authenticating handwriting to figure out whether a signature is forged or altered. The three big pillars of signature analysis are line quality. That is, if the line quality is smooth and the strokes are continuous, the writing is natural writing. Shaky or hesitant lines can denote for possible forgery. Then pen lifts where they shouldn't be can also denote for possible forgery. And we are also looking for rhythm, flow, speed, consistency. Like a real signature moves, a fake signature thinks. That is, a fake signature must have tremors or anything shaky or whatever. Okay. Then we have individual characteristics, the second big pillar. That is, these are the unique feature that develop over years of practice, the stuff that cannot be easily imitated, which includes personal habits, odd curves, unusual starting or ending points, specific letter forms, spacing patterns, consistent error. Even mistakes are also an evidence. Then we have the class characteristics. These come from shared training or background, not individuality. That is the schooling style, regional writing style, pen grip tendencies, use of certain flourishes. Class trait can't confirm authorship alone, but they build context. And the types of signature that you will see in the for example, in the genuine cases, the signatures are made freely, naturally by the person. In the simulated forgery, someone studies the original and tries to copy it. Traced forgery, either simulated from a model or literally traced with a light source. Next, we have freehand forgery, no reference, total guess, usually awful. And auto signing, stamp or digital, more common in corporate environment and legal documents. And we have to check in this activity is like letter shape, slant, spacing, and line quality, the basics. You can also go with the letter proportion, baseline alignment, connecting stroke, entry and exit stroke, retracing, patching, tremors if present, slant consistency, speed variation, pen pressures if you have any any visibility in this these two signatures that pen pressure could be or could not be present, it's on you. Next one, I think so. Next activity.
Yeah. Yeah. So, guys, you will be having one more activity. So, the choice is yours. You can do either the first one or this one. In this, it's as simple as that. We'll be comparing human handwriting versus AI handwriting. Both will be of yours itself, the same individual. So the first, what you guys will be doing is write a short paragraph or a question or a mathematic problem, whatever you want. Next, take a clear picture of that, of your handwriting pages, like normal page, which contains your handwriting problem, question, mathematic problem, whatever it is. So next, upload the image into an AI tool, most preferably Gemini AI. So, and you will be giving a prompt that generate the same text in an image, or else generate the solution for the question uploaded in an image using my handwriting style. So that we'll be giving AI to give an attempt to mimic your own handwriting. Next, as the AI generates the solution or the answer for your question that has been uploaded in your handwriting, make sure that must be in your handwriting. Download the image. Now you will be solving the same thing in your natural handwriting on the same page. So now, after you have both AI generated and naturally written handwritings, you will start comparing both the samples. You need to analyze like a forensic expert, where you will be analyzing on slant and spacing, pressure and rhythm, letter form and alignment, consistency of strokes. These are the basics of the comparison of handwriting samples. You'll be comparing, as I said before, letter shapes, slant and spacing, pressure pattern, line alignment, everything. Next, what you guys will be doing is, after comparing your natural handwriting and uh, natural handwriting and AI generated handwriting, you guys will write a short analysis, write a short summary on whether the AI handwriting looks similar, semi similar, or completely different from your own. If yes, so that's not like, I'll be asking only 3 questions after your analysis. You need to answer that too. That first one is, what did AI get it right? If it's similar or semi similar, how did it get right? Next, what did it fail to imitate? What did AI fail to imitate? Next, does the AI, just a second, I'll be taking a call. Hello. One ನಿಮಿಷ ago. Okay, next one will be, how does it look, natural or artificial? The handwritten generated by AI, is it natural or artificial? So you guys need to write a short summary on this, as the steps are here, and this will be shared to, I'll be sharing to Swapnil too. So he'll also be sharing with you guys. So yes. Thank you, and this is now open for your Q&A sessions. Mansha?
Thank you so much, everyone, for listening us patiently.
Thank you so much, speakers. I can already see that Mansha has been consistently answering all the questions that have been coming in the chat box. Still, the session is now open to the Q&A. So if any student has any questions, you are requested to raise your hands, unmute yourself and ask the questions, or else you can also put the questions in the chat box. Okay. Also, guys, I have shared a reference prompt for you as instructed by Mahanthesh. I have already shared that generate the solution or text in my own handwriting from the reference that I have shared in the picture on this same paper and use Nano Banana Pro for the same. This is the prompt or a reference you can say that you can send to Gemini and you can use Nano Banana Pro to get it. Okay. You might have seen the recent hype, right, in LinkedIn, in YouTube, and stuffs like that. If you are a consistent viewer of YouTube Shorts or maybe Instagram Reels, or maybe if you have gone through certain articles in LinkedIn, then you must have seen this. That many people are talking about it. That we have outdated verification systems, and AI can now properly mimic our handwritings. However, I want you guys as forensic scientists to test whether this is actually true and how correct is it to say that AI can absolutely mimic your handwriting. Like, as Mahantesh has already told you, you need to find the degree of similarity and write it down as part of this activity. So, if you guys have any questions, please feel free to ask the speakers. Mansha, I think there is a question from Navneet Singh. What are the challenges of deploying AI-based fingerprint systems in real-time applications?
Okay, sure. I would be answering the question. So, deploying AI-based fingerprint system in real-time application presents a lot of challenges across technical, security, ethical, and many other, divisions. And the main hurdles we can include is data quality issues, vulnerability to spoofing attacks, and the need for scalable infrastructure and other privacy concerns, I can say. And these are the basic technical and operational challenges that we go through. Yes, you can do one of the activities.
The submission deadline is the same next week, Friday. Okay, so please try to send it by next week, Friday.
Oh,
The one, Rishita, the one that we have already sent, the assignment, that is for yesterday's session. Okay, I would like to clarify, you will be having sessions on Saturdays and Sundays, right? So after Saturday's session, you would be getting one task. After Sunday's session, you would be getting one task. And you will have 1 week time and you can submit it by the end of the next week. That is Friday or latest Saturday. However, I would prefer if you comply by the deadlines and if you send it by Friday, then that would be great. Because I have seen that quite a few of you has already submitted me the task by yesterday and by today itself. You have to complete both the tasks, both as in yesterday's task and today's task. Among yesterday's two options, you can choose either one. Among today's two options, you can choose either one. And the submission criteria remains the same. You have to follow all the guidelines that have been shared in the group yesterday in the PDF itself. You have to submit it on Veritas Vanguard 1.2 at the rate gmail.com. That is the submission email ID, right? Any other doubts?
So there's the question from Niharika, right?
I
Anything in
was
forensic that AI have not yet replaced? Mansha, if you want to answer, you can.
you can answer. You can answer. I was answering till you were lecturing. It's okay. It's okay.
Yeah, yeah, I saw the messages. Okay. Niharika, as I said before, AI is just an assistant for us and it can't replace human forensic experts. First thing, it can't do crime scene interpretation and judgment. Like it cannot physically visit any crime scenes. Next one, there are some human responsibilities that need to be done. Like AI cannot appear in the court, defend a methodology, explain limitation, handle cross examinations. No, human forensic experts need to do all these things. And one thing in forensic psychology, when we relate this question to forensic psychology, it cannot be used in detecting deceptions, interviewing victims, profile behavior. AI lacks these like anything that humans can be done. And there are many fields where in forensic science AI have not yet and can't replace humans, like entomology, anthropology, those things, field-based forensics, soil forensics, like insect progression assessments, ethical decision makings, reconstructions of fire explosion accidents. There are many list of the things where AI cannot replace humans, but yes, that can just assist us, not replace us. Yeah, I guess I'm clear.
Okay, so we have the next question that if a government seal is duplicated, then what are the things that will be helpful to identify the fake? Okay, so we have to basically check for the imperfections like the uneven lines, the blurry edges in the impression or the asymmetry, and we can compare it with a genuine seal to see the design flaws, and also we can look for a unique digital identifier जो कि आजकल in the modern techniques they are used, like a QR code or a hologram on the document, and verify the documents detail online through the official government portals, as fake often lack these security features or have inconsistencies. And authentic seals also have sharp and clear details, and fake might be appearing as smudged or blurry ones, or having the missing parts of designs. And ink impression, we can check if the ink looks inconsistent, too dark, or if the impression is too light or too heavy in the places. Okay. And we can look for unique numbers like IMEI for phones, or specific certificate numbers which can be verified on relevant government sites. For example, Times of India can also is also indulged in this for making the unique identifiers and everything. Hope so that is clear to you.
So there's a question from Navneet Singh. Can hence be used to synthesize realistic fingerprint images, and what are the implications for biometric system security and spoof detection? Mansha,
Yes.
like,
Okay, I have to answer. Okay, so the generative, adversarial networks, that is GNS, they can be used to synthesize realistic fingerprint images. These are oftenly visual, indistinguishable from the real ones, and they even possess the necessary features like the minutiae and the ridge patterns to deceive some modern biometric recognition system. And we have positive implications like data augmentation and testing, development of many robust systems. And also the negative implications we are having is spoofing attacks and the creation of master prints, because if everything has a pros, and it is also having a con. Hope so I'm clear to you. Okay, then we have in the cases where a forger is highly practiced and capable of producing skill signature, is visual comparison alone sufficient, or the examiner needs advanced tools or instrumental analysis to reach a conclusion? See, Disha, visual comparison alone is insufficient for reliably detecting a forgery, a skilled forgery basically. A highly practiced forger can produce a signature that closely resembles the original one. So we have the limitation of visual comparison, that is hesitations and tremors. The pen may slow down at certain point, but वो कहीं ना कहीं हमें visual comparison में नहीं दिखता है. And inconsistent pen pressure and ink flow, and blunt starts and stops. No, and there is a need for advanced tool and instrumental analysis like microscopy, VSC, as we had discussed. Then we have SDA. Then we have chemical analysis like TLC or microspectrophotometry. And the more advanced tools are used. So hope so I'm clear in this. Yeah, Khyati, you have a doubt in assignment. Swapnil, can you please go through Khyati's question? I'm unable to understand.
Sure, just give me a minute. I have a doubt in the assignment why there are two timings for text from neighborhood. Okay, so there are two timings from the text from neighborhood. Okay, I think you are mistaking somehow because I think there are two timings. One is when he receives the text from the neighbor, and the other one is when his son gives him a missed call. But then again, guys, I told you, right, that it's all about questioning. It's all about knowing what to question. So if you are finding actually that there are two timings given, two timings mentioned, then please question it. Okay? You can write that in your observations, no issues. If you find some inconsistencies, then please question it. Also, guys, this is a general instruction again that I have been receiving multiple texts from you guys that the deadline extension, sir, I won't be able to join. So, guys, I would once again like to emphasize that for me alone, it is not possible to keep a track, right? इतने सारे बच्चे हैं. There are so many students. It's not possible for me alone to keep the track of everything. That's why please reach out to the dedicated program coordinators. In the group, there are two program coordinators, Abhishekta and Mansha, as we had discussed this already in the orientation session. Both are there in the group. You can reach out to either of them. दोनों को reach out करने की जरूरत नहीं है. You can reach out to either of them, okay? And you just tell them their problem, your problem, and they will give you the extension. ठीक है? So apart from me, मेरे अलावा whoever is in the group as admin, वो program coordinator है. तो आप उनको reach out कर सकते हो, right? But still, if you have any other doubts, you can definitely give me a text. कोई दिक्कत नहीं है. So, is there any other question? Any other question, guys?
Sir,
Yes. Okay. So, I think there are no other questions. Then let us conclude the session.
Good evening, sir.
Yeah. Yes.
Sir, as some of them has texted me due to the exam going on, so they need extension. So I have already texted them back so that they can take some time because some of them are having same exam and some of them are having
Sure,
some.
Abhishek. Sure, that would depend on a case by case basis. So depending on their examination dates, you can provide them an extension. So please try to give the extension dates 1 week from their examination end. Okay, from the last day of their examination, so that they can have plenty of time, at least a week to complete their assignments. Will that do, guys? Any issues? 1 week from your exam dates is fine, right?
It's fine.
Okay, great. So thank you so much once again, Mr. Mahanthesh and Ms. Mansha. Mr. Mahanthesh, your insights into the technicalities of forgery detection and the nuances of latent prints were incredibly detailed. The way you broke down the analysis of those samples really highlighted the patience required in this job. And Mansha, thank you for bridging the gap between theory and innovation. Seeing your transition from our host to a subject matter expert was truly inspiring for all the interns. This concludes our first weekend of Veritas Vanguard 1.0. Dear interns, you now have your tasks assigned for this week. based on yesterday's and today's session. So please remember the deadline for submission is the next Friday. In case of extensions, as I have repeatedly mentioned, please reach out to the dedicated program coordinators. Work hard, stay original, and use the group for doubts. Okay, in case you have any doubts, please feel free to reach out. We will see you all on the next module on the next Saturday at 5 p.m. Have a productive week ahead. Bye bye.
Thank you, everyone.
Thank you, everyone. Thank you, Swapnil.
Thank you, sir. Thank you, ma'am.
Regarding the PPTs, it will be posted. Okay. It's okay, Khyati, no issues. I always encourage you guys to question. The PPTs will be posted. Yesterday's and today's recordings will also be posted in the YouTube, okay? And I will share you the links by today itself. Don't worry about that. Thank you so much once again, guys. Have a great evening ahead. Bye-bye.